Today we're going to take a look at how to prove triangles are congruent using the things you've learned about side, 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 side angle, side, etc. When would you use these in real life? You probably won't. But geometry teaches us how to think logically, one step at a time, providing facts for what we know. So working a proof is like getting a box of something that has to be put together. I'm giving you some information, and you have to use that information to prove this. So it'd be like if I gave you a cookie sheet full of flour, sugar, butter, and eggs and said, prove to me that you can make cookies out of this. I give you the supplies, you prove to me that you can bake. So we're going to start by marking up the picture. Given angle ACD is congruent to ACD. So ACD would be this one here, is congruent to, that should be ACB. ACB over here, okay? I also know that BC is congruent to DC. Well, now I got to think about where to go next, because obviously I need one more part. So we think about what we learned in a previous lesson, side, side, side. Well, I don't know anything about those two sides, so that may not be a way to go. I've got side, angle, side. Possibly I could do something here. I've got angle, angle, side, but I only have the one pair of angles, so that's not going to work, and that one's not going to work. So what we always start with is the idea of, I know this because, statements and reasons. So what I know is that angle ACD is congruent to angle ACB. How do I know that? Because it was given. I also know that BC is congruent to DC. Well, how do I know that? Because it was given to me. It was part of my box of parts. Now I got to take a look at other things I might know. Well, what I do notice here is that if I drew these two triangles separately, they would both get side AC. So this is a shared side. Because it's shared, it has to be congruent. So I'm going to go with AC congruent to AC, and that's by something called the reflexive property. Think about reflections from when we did them in transformations. Now I can see what I've got. I have a side, an angle, and a side. So I can finish this by saying that triangle ABC is congruent to triangle ADC because of side, angle, side. So I've given reasons, statements and reasons that prove that these two triangles are congruent. Now this one was kind of kite-shaped. The next one is shaped like a bow tie. Again, I want to mark up what I know. I know that angle J is congruent to angle F, and that FH is congruent to JH. So now I got to think about, okay, where could I go with this? Well, let's write down what we know. Again, I know that angle J is congruent to angle F because it was given. And I know that FH is congruent to JH. Again, it was given. Now I got to find something else. Well, anytime I get a bow tie shape, something's happening right here. You studied again back in the transformations unit the idea of vertical angles. So I can say that angle FHG is congruent to angle JHK by vertical angles are congruent. Well, now that I have that, triangle FGH is congruent to triangle JKH by angle, side, angle. So just taking what we're given and then putting a little thought into what other pieces go together. Okay, finally, we've got a different one over here, and this one could be done in a couple of ways. MP bisects ln. Remember that bisects means it cuts it in half. So this thing here cuts this guy in half, which means those two pieces have to be congruent. MP is perpendicular to LN. Perpendicular means we get right angles. I'm told that the big triangle, LMN, is isosceles. And if you remember, isosceles triangles say that two sides have to be equal. So now I can do a couple of things. One of the things I noticed right away is I've got the hypotenuse and a leg because it's a right triangle. So I could be done that way. So one way, and instead of recopying all my givens here, I'm just going to go 1, 2, 3. If I do statement 1 is given, that told me that LP is congruent to NP by definition of bisect. Then I'm going to use statement number 2 from up here, that NP is congruent to LN because it's given. That tells me to go with that angle MPL is congruent to angle MPN by definition of perpendicular. And then my third statement about the isosceles, I can finish with saying that LM is congruent to NM by definition of isosceles, and I can finish by saying triangle LMN congruent to triangle MNP by hypotenuse leg. Or if you're unfamiliar with hypotenuse leg, just like in the first example, I could do or MP is congruent to MP by the reflexive property, and then my triangles would be congruent by side, side, side. So there's often more than one way to get to the answer when we work on these proofs.